This is the prof. Good day. Wait for it. Yes, and here we are. Okay, you can see from my previous videos that we've done something similar to this along this line. Titration between hydrochloric acid and sodium triisocarbonate for decahydrate. You know, I told you there are different modes you can have for questions, different ways, different patterns question can be asked. So this is another way. Please, if you have not watched the previous video, go and watch it. Go back, watch the video, subscribe, share. Very, very important. Now, what I'll be showing you in this particular video will be how to do these calculations. If you see these calculations, the questions that are here now, you can see I included something about volume of carbon dioxide at STP. Why? Because when hydrochloric acid reacts with triisocarbonate 4, there is going to be evolution of carbon dioxide. Don't forget that there's going to be evolution of carbon dioxide. Okay, so let's go into the solutions now. So you have your equation of reaction there. From your equation of reaction there, you can see Na, that is number of moles of HCl, is 2. Then Nb for the base is 1. Note, my assumption here is that I am using 20 cm cube, alright, 20.00 as my volume of acid, my average titer. Okay, so you are going to use your own too. It doesn't have to be 20. So this is the one I'm using in my calculations. Use your own too. So I'm asked to calculate the concentration of B in gram per dm cube. If you look at the question, if you go back to the question, you'll discover that you are given 7.15 grams of B in 250 cm cube. 250 cm cube. What you need is to change it to 1000 because your mass concentration must be in grams per dm cube. So, and this is how you do the conversion. There are two methods that you are seeing there. You can use any of those two methods. You will get your answer. Okay, you will get your answer. Then, number 2, you are asked to calculate the concentration in mole per dm cube. You are going to use the formula molar concentration is equals to mass concentration over molar mass. This formula, you can also change it to mean mass concentration is equals to molar concentration times molar mass. That's if you cross multiply, you can do it in different ways. So, but this formula is very important. Don't forget that. So, since I've just calculated mass concentration of B to give me 28.6 over molar mass, you know your B is sodium triisocarbonate for decahydrate, alright? So you are given the atomic masses. Sodium is 23, oxygen is 16, carbon is 12, hydrogen is 1. Alright, if you input all those atomic masses in the molecular formula, you are going to have 286. Na2CO3 alone is 106. 10 water, that's decahydrate, 10 water. You know water is 18, molar mass of water is 18. 10 times 18 is 180. If you add it to the 106, that is where you have the 286. So 28.6 over 286 will give you 0.100 mole per dm cube. You must write unit or else you lose the marks, and it must be three significant figures. You can't say 0.1, no, 0.100 mole per dm cube. Don't forget that, please. Here I'm to calculate concentration of A in mole per dm cube. Molar concentration of A. So why am I not using molar concentration is equals to mass concentration over molar mass? The reason is that I am not given the mass concentration of A, so I can't use that formula. I have to use CAVA over CBVB is equals to NA over NB. Remember, my VA was 20, right? The one I assumed. Then VB is always a constant, the volume of your pipette, that is 25 cm cube. So CB, I've just calculated it to be 0.100. My NA is 2, my NB is 1. If you input all those values, cross multiply, you will get your CA. It's very simple and straightforward. In this fourth question, I'm to calculate mass concentration of A in grams per dm cube. Don't forget the unit of mass concentration is gram per dm cube. So you can see now I can use the formula mass concentration is equal to molar concentration times molar mass. Why? Because I have molar concentration and it is very easy to calculate molar mass too. Then I'll multiply them. Alright, so the molar concentration of A that I've just calculated is 0.250. Molar mass of A, remember A is HCl, hydrochloric acid. H is 1. Cl, chlorine, is 35.5. If I add them together, it will give me 36.5 as the molar mass of hydrochloric acid. So if I multiply, it's very simple. I will get my mass concentration. Don't forget, you must always put the unit and it must be 3 significant figures. Do you see that? You can't say 9.135. No, that is 4 significant figures. 9.13. If you have to approximate, but it must be 3 significant figures. Then question number 5, I'm to calculate volume of carbon dioxide at STP. Remember, according to Avogadro, 1 mole of any gas at STP occupies 22.4 dm cube. Any gas at STP, 1 mole will give you 22.4 dm cube. So I have to know the number of moles of gas produced in this titration. To know that, I have to calculate the number of moles of sodium triisocarbonate 4. That is my B in this titration, because it's the sodium triisocarbonate 4 that will produce the carbon dioxide. And how do you calculate number of moles in volumetric analysis? It is concentration times volume. Your volume must be in dm cube. So my concentration of B is 0.100. Then my volume is 25, right? 25 cm cube, volume of your pipette. 25 over 1000 is to convert to dm cube. Will give me 0.025 dm cube. So if I multiply by 0.1, I will get the number of moles, which is 0.0025 mole. Now, since I'm having 0.0025 moles in this titration, if you look at the equation of reaction, 1 mole of B, sodium triisocarbonate 4, decahydrate, will also produce 1 mole of carbon dioxide, which means 0.0025 moles of B will also produce 0.0025 mole carbon dioxide, right? Since you already know that 1 mole of carbon dioxide will give me 22.4 dm cube as volume, but now I'm having 0.0025 mole. What do I need to do to get the volume? I'll just multiply by 22.4 dm cube and I will get my answer. The last question asks us to calculate the amount of A in the titration or in the average titer. Alright, amount also means number of moles. Remember the formula for amount, number of moles. Remember the formula, concentration times volume. Your volume must be in dm cube, which means you have to divide by 1000. And what is my volume of A that I started with? It was 20. My own average titer, it was 20. So if I divide it by 1000, I'm going to have 0.020. Alright, I divided by 1000 because I have to convert it from cm cube to dm cube. That is just it. Once my volume is in dm cube, I can now multiply it by my molar concentration of A. Then I will get the amount of A in the average titer.